On question number 2, we want to find the area of the shaded region. First, we're going to find the area of our hexagon. And you can do a hexagon as 1/2 AP, or I'm going to do it as an equilateral triangle. There's 6 of them. So if I draw in my equilateral triangle here, I know each side is 10. So to find the area of an equilateral triangle, it's the square root of 3 over 4 times my side squared, or square root of 3 over 4 times 100. So the area of my hexagon is 25, not my area of my triangle, I'm sorry, is 25 square roots of 3. There are 6 triangles though, so I got to multiply that by 20 or by 6, so that will be 150 square root of 3, and that's the area of our hexagon. Now it looks like we have a rhombus for the white region, so let's find the area of our rhombus. The formula for a rhombus is 1/2 diagonal 1 times diagonal 2. Well, if I draw in my diagonals, let's erase that part from the hexagon. Let's just work with a rhombus here. I know one diagonal, that'll be 20. So it's 1/2 times 20 times my other diagonal would be 10 square roots of 3. So we get half of 20 is 10. 10 times 10 is 100 square roots of 3. So my shaded region is going to be 150 square roots of 3 minus 100 square root of 3, which is 50 square root of 3. But I want to round it to the nearest tenth of a centimeter, so I don't want the square root of 3. Probably could have been working with decimals the whole time. I chose to work with the square root of 3. So 50 square root of 3 is 86.6 square centimeters. And there's your answer for that question. Question number 3. I want to know the diameter of a circle with an area of 5. So we know it's A equals pi r squared. I know my area is 5. So then I'm going to divide both sides by pi. So r squared is going to be 5 over pi. Or, getting ahead of myself there. R is the square root of 5 over pi. I want to find the diameter, so I'm going to double that. I'm going to take 2 times the square root of 5 over pi, and then I'm going to round that answer to the nearest hundredth of an inch. So if we take 2 times the square root of 5 over pi, we get about 2.52 inches. Now, we have the circle on question number 4 with a radius of 3. And the sector of a circle has an area of pi square inches. I want to know what the arc measure is. Well, in other words, I know this sector here is about pi square inches. So I know the area of a sector is the measure of the arc over 360 times pi r squared, times the radius of my circle. Well, in this case, I know it's pi, right? I don't know the measure. That's what I want to find. Times pi times 3 squared would be 9. Well, I can reduce that a little bit. 9 goes into 360 40 times, doesn't it? So I get m over 40 times pi. Notice I can divide both sides by pi. So 1 equals m over 40. Well, that just means m is 40 then, isn't it? Because 40 divided by 40 is 1.